Hello and welcome to Practical Approaches to Problems in the Financial Industry. I'm Andy Fundinger. This is Mario Morales. What we're going to do today is kind of walk through a typical-ish financial project and show some of the characteristics and show what they tend to look like, especially to give a taste of what's typical for that kind of project compared to a web app or compared to this or that. A little bit of a disclaimer, we are using a risk management system as an example. This is a tool that you typically don't have access to for your own investing, and the output from this is not particularly relevant. We wouldn't actually recommend taking this and trying to use it for investing. It will not do what you think. But that is our end goal. We're going to build a little personal market risk management platform. What it's going to do is show some degree of risk for each mutual fund, and the idea is that you would have this information and then think about where you want your risk and where you want to not have a risky investment. Typically you want to have risk in your retirement fund in something that you're going to be using sooner. You don't want to have as much risk, like a down payment for a house. This is a sort of thing you can Google the math for, but actually getting it to work is trickier to do, enough to make an interesting case.
Could you speak a little more?
Oh, is the mic not picking me up?
It's fine.
It's fine when I'm close. If I wander around, then I don't. Shucks, because I like wandering around. Okay. A few definitions, just so everyone can follow along on the same page. An asset is, these are all pretty much what you think they are. An asset is something valuable, a stock, a bond, so a euro, something of value, and in this case we're talking a financial asset, so you value it, someone else values it, you have a good chance of being able to sell it. A holding is a quantity of an asset, 5 shares of stock. A fund is a collection of holdings, basically a mutual fund. And then a portfolio is a group of fund investments. Everything you own, all your retirement investments, something like that. Just a hierarchy. So without even looking at what we're building, financial systems always are going to be looking for 3 things. They're going to be looking for data on the holdings, what assets are being analyzed. They're going to be looking for market data, and then they're going to be looking for computation methodologies. So this is a risk system. The computation is going to be risk, but we'll start with the holdings and the market data. So we're getting data, in this case, from Motif, who has graciously allowed us to use some of their funds, their motifs, for sample data, and Quando, who makes a business of providing data free for everybody. It's a really cool service. And they also do something you'll find typically in enterprise. They'll give you scrub data. So they'll take the best of Yahoo and Google and possibly some other corrections, put it together, and let you grab that. So we have no permission from them because their terms of service say use this data. So starting with the funds, what we want is to be able to do something like this. Take a fund, take our retirement fund, look at the components, and get a Panda data frame. Take a fund, RIP fund, look at the components, get a data frame. Maybe we want to index it. That might be convenient for looking across and such, so we just implement it both ways. The code to do this is roughly what you'd expect. We're going to be doing this a few times, so we have a base class. We cache whatever we created. We override getAttr and getIndex, and we say, use the cache or create it. In this case, we're using a file, CSV files, read it in, turn it into a data frame as your create sub-object. And in order to make it work as a fund, we're going to actually use this object holder, which just takes a class and wraps it. That class is a little tricky because what we actually want to do is have everyone using this use our funds as though they were the data frame, not constantly be pulling .component off of it. The reason for that is we're anticipating a requirement to tell someone what data was used or to do some kind of transformation. That winds up being very typical. So in this case, we have them start using just directly off the fund as though it were the data frame. And we're actually proxying all their access into the data frame. So you can see how this is done. Get item just redirects, get adder redirects with a check for underscores. We'll leave those alone. Length does the same. And then an example of how this gets used, if we call the start date min, it actually just goes right into the data frame and finds the min using the built-in pandas methods. So we're not implementing min and everything else under the sun. So market data, hey, guess what? We want about the same thing. Market.fx, give me the USD euro rates. Here's 3 of them. Market.stock, give me the IBM stock. Here's a date range. Here's everything. And guess what? We want to do the same trick. Market.stock.goog.describe. Hey, look, here's all the basic statistical breakdown on Google's stock across the entire range of what we have in the data set. Now, it is a little bit trickier pulling it from quando. When we pull it from quando, we have a couple of complexities. One is we have to find out what quando calls the thing we're looking for. So either we have to provide a map, a dictionary saying, when we ask for this name, go to quando and get this name, or we have to give it a prefix because quando has different data sources. As I mentioned, we're using the wiki and the quandl data source, both of which are clean data sources for stocks and FX rates. So depending which one we apply it and we look it up. And then for the asset, when you go to access the values off of it, which is of course actually hidden behind getAdder and getItem, we check whether it's in a cache, because quandl's going over a web service, and pretty much even with the size of, you're pretty much going to hit rate limits if you go requesting it every time, so you do need to cache it. So we check if it exists. If it's in the cache, we use it. Otherwise, we check if we hit a rate limit already, and we retrieve it. Obviously, you could do a little bit better for rate limits, and you can improve caching, but this is an example, and it's a problem you need to deal with, even if you can't just skip it. Okay, so then we get to the computations.
Okay, so we are using just a traditional value address. The two original documents are the arithmetic document from 1996 and the book of Philip Jorion about value address, so you can find that. So the idea is just to check in a simulated portfolio where, or with a certain confidence interval, what are going to be your expected losses. So the idea is you model a distribution, you generate all simulated values for your portfolio based in a few parameters that you have for that distribution. You subtract that for the current value of the portfolio, and then you check what are your possible losses. So we had two approaches. One that I'm going to show you, which is just for one portfolio, and then I'm just going to show you a historical simulation that is going to generalize this concept. So the computation of the value at risk is just under a specified probability or confidence interval give me what is the expected loss for my portfolio. The references that I recommend are in the frequently asked questions in quantitative finance by Paul Wilmot, and we are taking functions from a repo from Olaf Smith about a book of Monte Carlo methods in finance. So you can check both, which is the original functions plus how we adapt these examples. In this case, for example, we have a set of weights, portfolio composition, and then what we are doing is just what I described by pulling data from the information or from the framework provided by Andy, and then I am applying just this basic math. So I had a initial position, which is this is sub-zero, and then and I also have the log returns. I have an horizon of 5 days to compute my value at risk. I use this function called simulated loss historic, which is just this. You see the line simulated price n. You have the initial position, and then you have a set of bootstrapped indexes to generate some random number there, and then that's what we have. And finally, I compute the simulated loss with the simulated portfolio minus the current portfolio. Then I check the 95 quantile percentile, and that's how we compute value at risk.
Okay, so one way to do this, as Mario just showed, was you go ahead and you look at what statistically the market data has been doing, and you get simulated markets by taking that and shuffling them around and generating markets that seem reasonable. Another way to get markets that seem reasonable is historic simulation. In this case, if it happened before, it seems reasonable. There's, of course, pros and cons to everything. The big thing here is this has less assumptions, and the even bigger thing is it's easier to explain. Probably because it's easier to explain, it's actually been written into a lot of laws. And a lot of people and a lot of processes prefer this. A good chunk of that is just you can explain to a regulator what it's doing. And a lot of this sort of thing is regulation driven. It's also absolutely reasonable to say, what would be our risk if something like 2008 or if something like an oil crisis happened again? Go back, get the market data, take a look, see what happened, and whatever happened is your risk of what will happen. So in order to do this, though, we need to find out what our portfolio was worth if that happened or when that happened. And that's quite often the major challenge in this system, pricing. Pricing is loosely like this. We want to price a holding. A holding looks like a dictionary. It's got information about a holding. What stock, or what instrument type, what instrument, how many of them you have, price it. Okay? Conveniently, those are the same columns as in those fund data frames from the beginning. I may have set that up. But also, they're there because that's what's needed. So it's just the same, we price it. This actual price holding function is a little tricky. We take in a holding, we take in a market, we take in model, and we take in what date we want to price it on. Then we're going to look up a pricer in this dictionary of pricers by the instrument type, pass it all the information, and assume it's going to give us a price. We have two of those, price FX and price stock, because they're pricing a exchange, a foreign currency holding is a little bit different than a stock. A stock is simple. How much is it worth today? How many do I have? Multiply, done. A foreign currency is a little bit trickier. You need to say, what is my currency? What is that currency? What's the rate between them? Divide the number I have by that to find out how many they're worth in my money, and then you have the price. And things only get trickier from there. We're quite intentionally not doing bonds, derivatives, options, because they would fill the screen and not be all that beneficial. We did, however, put in a decorator to anticipate that. So what this decorator does, you decorate a pricer, and it registers it into that dictionary. So as more pricers get added to the system, this will just let you say, here's a pricer, here's a pricer, here's a pricer, and the system's capacities increase. So with a pricer, then we can price a fund. So we just extend onto our fund object, price holding, price, and we use the data frame apply function, apply pricing across all of it, sum it, and then we've got the price for the fund. For a portfolio, almost exactly the same. Apply the fund's price across all the funds, multiplying by the quantity of holdings you have in the portfolio, and off you go. Once we can price in the past, and we can get that historical var. So in this case, we need to have all the dates for the last year, take all the dates, price for all the dates, subtract the 95th percentile price from the current price, and you've got the historical var. Not surprisingly, it's the same for a portfolio. Only difference is it needs to know what the funds are so it can look them up and find out what holdings are in the fund. So once we have this, we can price it, we can get historical vars. What do we do with that? Operationally, we would run this nightly. We would kick it into some kind of output, and we would look at something like this. Here's two portfolios. One is all IRAs, bunch of retirement stuff. Here's a portfolio that's intended to provide a down payment for a house. Well, looking at this, the odd thing is the risk per dollar, the normalized HR, is higher on that down payment, which you probably want to use sometime in the next few years, than the retirement fund, which probably can tolerate more risk. So you look at this and you go, I'd like to do something about that. So what's in there? You can see there's three funds in here. Three funds in here: RIP, Senior Care, and Fighting Fat. And if we look at our list of all the funds, we see that that RIP fund is a very high-risk fund. It's actually a bunch of mortuary companies, I think, which I thought would be fairly stable, but apparently is not. So what would happen if we took that, liquidated all of it, and threw it into blue chip companies? We have a fund up here, Dow Underdogs. That's a bunch of Dow Jones Industrial companies that are not doing well this year. At least they're stable. The normalized HR on them is extremely low. So we convert the fund, dollar for dollar, and replace that RIP fund with Dow Underdogs. And then we can look and see how these compare. And that's cutting the risk almost in half. Incidentally, you're cutting the returns too. I mean, Dow Underdogs, I took a look at its performance. It's been consistently down always. I do not, well, I don't recommend any of these funds, but I was quite unimpressed by that. But it's low risk. So, and of course, you would do that periodically. You would do that as you're concerned. The actual use in a large financial institution also includes limit rates monitoring. So you would say that we have too much risk. Now we need to do something. We have too much risk across everything we own. Let's do something about that. So that's where our example ends. What's missing? Typically, after you have something built, you have to validate and approve it. You go through model review, you get regulators to approve it, and even if you don't do that, you do a process of back testing, where you check to make sure that its results consistently match with reality. Also, typically, you'll have enough trouble, you'll have enough data flowing through this that you need to distribute the computation. Some of those pricers will flat out take a long time to run, like a second or two per date, per price, and you'll be doing thousands of those. for each one each time. Also, and those would be the more complex pricers. Some of them actually have to simulate things just to get a price estimate. Also, VAR is a very simple metric to calculate. You would probably want some others. You would want standard deviation. You would want some even higher order ones. The other omission here is we are not handling any asset that we don't have market data for. If we're going back a year's worth of market data in order to find out, and we don't have a year's worth of market data, there are ways to handle that, but we're not doing it. That's time for questions.
You mentioned something about going back into history and looking at how someone would perform, let's say, in a crash.
Mm-hmm.
You could safeguard yourself quite against that.
Right.
Now, have you guys actually tried looking at, let's say, the market crash of 1929 and running simulations based on that model for the recession of 2007?
So this is, I mean, nothing I'm showing here is new. The typical regulations say something like, find the worst year in the last 5 and run for that. The problem is as you go further and further back, things don't work like that anymore. Like the influence of horse and buggy companies on the world economy has diminished significantly since 1929.
But the market behavior of whatever company you're looking at, that the trends would be similar. So if everybody wanted to buy a horse and buggy, like today everybody wants to buy an iPhone, there would be correlation in behavior.
Yes, but matching that would be effectively impossible. I mean, what do you match an iPhone to, and who matches to Google? And oh, sorry, did you have something further on that?
The other problem is the availability of data. So it's 1970, 1980 when you start finding time series that are, if you want to check that, you need for that crisis. So you can find that in monetary policy books.
And what is done for that is they sit down and they do an academic study and say, we think this is done for the oil crisis. They go, we think what's reasonable is take everything in the oil sector and bump the price up. And don't use today's data, it doesn't matter. So for missing data in this example, I used all stocks that were available in the last year. Yeah, you can. Like, yeah.
So for bar, you use generally available data in a recent scenario. But if you want to execute a study, then you had you can correlate how your stock behaves with respect to something historical. Take that historical, generate that distribution, and then generate your simulation base in that. That's what you can do. Other thing that you can do, yeah, something that is similar, yeah. That's what people do. And other thing that when you can use to handle data, missing value data, because for example, you had a problem in the market or the provider, so use a library for missing value imputation. So essentially, like for example, Andrew Gelman provide a few missing value imputation libraries in both languages, in ARA and Python.
And the one actually being used for single day missing data here is we just forward fill it. Because missing data here probably means the stock market's closed. Yeah.
And if you really want to filter, you find stocks that correlated to it, that about take the average of them and fit that value in.
Yeah, yeah.
I mean, average increase.
Yeah, that's another way to do it. You could look for correlated stocks and fill it in. That's probably what the libraries do. fill with the correlated.
Yeah, there's an expression in the financial industry that during a crisis, all correlations go to one.
Yeah.
So how does VAR handle that?
So the question was, there's a phrase that in a crisis all correlations go to one in a crisis. Right. So VAR, it depends how you calculate it. The method that I showed was a historic simulation. So the crisis looks like any other day, though in most cases you would exclude the crisis and say, so also this goes into the definition of VAR. VAR is how much you expect to lose on an average day, to, in this case, 95% certainty. So that means 15 days out of the year, you expect to lose more than the numbers shown. Okay? One of the things that was shown from Mario's section, actually, Mario, you want to show the expected?
And also your critique is valid in theory, like Nassim Taleb, he said that those are the black swans. So when you have a crash, nobody can predict it. That, unfortunately, and it's out of control. Yeah, we have something more acid than VAR, which is called the conditional VAR, or the expected loss, but still is not. It doesn't handle those cases.
Other questions? I thought I saw one over here. Oh, okay.
Just to add to what was said here, my boss always tells me that every mathematical model you've ever built is almost certain to be wrong. So you can't, expect 100% accuracy from a model ever.
Yeah. No, arbitrage, if there is a model that actually predicts anything, someone will build a trade to profit from that prediction. VAR or anything else is making a guess. It's making something that can be compared. It's making something that's probably equally wrong as everything else. And that gives you some numbers to work with. But it's required regulatorily for our financial institutions to stay in business. And incidentally, it does tend to work slightly.
Absolutely. I mean, there are days where it will not work.
Right.
Blame the mathematical model.
Yeah. The back testing I mentioned actually requires you have days where it doesn't work.
Also, VAR is a control and regulatory measure more than something to make profit. So the idea is to control the guys that are doing transactions with that kind of stuff. It's not, and the other is to have limits of loss for financial institutions. That's why it's not recommended to have a personal VAR, because the real cost of in financial institutions are the cost of doing transactions in big portfolios. So they accumulate that, and then those sunk costs they absorb all of those. But individually, you don't apply that. Yeah.
Yeah. Yeah, the question, I'm not sure where the question goes to, but the point is that as we're standing here, the 2008 crisis has just rolled out of that 5-year window, which is somewhat important regulatorily, which means that a lot of these measures, the banks are saying, oh, we have less risk because the measurements have just rolled off. Some of the regulations have some provisions to floor that, to say, like, well, it's 3 times normal or the worst of 5 years, whatever we see, whatever's available. But there's also a logic that it's not going to happen exactly like 2008. And since then, major institutions have changed, grown, shrunk, changed hands, changed business models, etc. So at some point, we have to give up 2008. We could wait till we have another crash. There are certain tests that are like oil shock. You must do an oil shock that's basically simulating the 1970s under the Carter administration, 76 or so. So there are things that don't go away, but there's things that do.
With regards to that, there's actually a measure called stress bar.
But stress bar has a 5-year, is usually the worst market from the last 5 years, or the worst 200 some odd days, worst 250 days in the last 5 years.
So that's what you're talking about.
Yeah. So we're rolling 2008 out of most of the stress bar windows. You can use anything, but I think there's one that uses the entire last 5 years. Some solid requirement for it. I think I saw a question over here. Yeah. We're using only Panda data frames. Little SciPy.
All that is integrated in the scientific library, so SciPy, NumPy,
Quando makes an access library.
The optimization libraries.
How recent is the data? I mean, like, is it like, if I want to pull up, say, let's say it's 12 o'clock, can I get data that's newer than a minute old or something like that?
They do 1-day resolution for most of their data, so it's perfectly suitable for historic. Quantopian might help you if you want fast data. They'll let you implement a model and run it against. Okay.
Last question about you ran Monte Carlo simulation here, right?
When I was on the part that Mario did, there's a Monte Carlo simulation.
What was your sample size? And I don't know, I always ask this question: what random number generator did you use? There are some that just don't let themselves go to Monte Carlo.
What I have here is Bootstrapping, and I have 1,000 samples. That's what I have.
How many realizations did you do? 1,000?
No, it's just one realization. Of course, you can extend this, but yeah, it was basically.
Yeah. Sure, it's just a matter of coding. I was actually hoping I'd have time to implement like a Newton's method optimization to play with it and to pull in some estimate. But depending what you do, you have to put some parameters around that. If you really wanted to, you could get your absolute minimum risk, according to methodology here, by just throwing it all in this fighting fat fund, which actually has a negative risk at the moment. It is so low that you're almost certain to have it go up by random fluctuation. That is mathematically correct. That is mathematically meaningful. You might want to look at it before you put your money there. That's, some weight loss company is doing very badly today, and risk management would not necessarily say throw all the money at it because they're doing a bad day. So, yes. Any other questions? Okay. This is up on GitHub and Prezi. So thank you all.